In this video, we are going to expand out from finding the inverse of linear functions to doing some inverses that require more steps. Okay, so here's our first one. You'll notice that this one is not linear because instead of having x to the first, it has x to the third. So this is a cubic equation. But you'll be happy to know that the steps are the same no matter how complicated your equation gets. We're just going to practice with the more complicated equations, even though the steps are the same. Okay, so look back in your notes from last time. Remember step one? All right, step one was to put y in place of f of x. Okay, so let's start off with that. Change that to a y, leave everything else the same. All right, and then step two. Step two is to swap your x and your y. So I'm going to swap my y for an x and my x for a y. All right, and then step three. Step three is to solve for y. So that's where this one is a little bit different than last time. It's not that we're not solving for y, it's that sometimes when you solve for y, you have to do some additional steps. Okay, so let's see what we need to do on this one to get y by itself. So I can see I've got y to the third here. I need to move the 2 and the -4 away from the y. So inverse operations, I'm going to add 4 to both sides. And then I'm going to divide both sides by 2. All right, I'm going to choose to do each one separately here. So I'm going to get 1/2 x plus 2 equals y to the third. Okay, so this time I have an additional step because I have this exponent here. So I need to do the inverse operation of this. So the inverse operation of cubing something is doing the cube root. So I'm going to take the cube root of both sides. Cube and cube root are inverses. They cancel one another out. So I've got the cube root of 1/2 x plus 2 equals y. All right, and now I've got y by itself, so I'm ready for my last step. I'm going to replace y with f inverse x. And then I'm just going to copy down what I had, 1/2 x plus 2. So there's the inverse of my first function. All right, let's try another one. Okay, so this time I've got a square root. Again, I don't have something that's linear. I have a square root, but the steps are going to be the same. I'm going to start off by putting y in place of f of x. Okay, then my next step, swap my y and my x. So I'm just going to switch those out. All right, and then my step that's going to be a little bit different, solve for y. Okay, so let's look at this one. What do I need to do with this one to get y by itself? Well, I can see that the most outside thing in this case is the square root. So the first thing I'm going to have to get rid of is that square root. Inverse of square root is square. So I'm going to square both sides. Okay, now still working to get y by itself. So now I need to subtract 5 from both sides. Just to save time, I'm not going to write that part down. And divide both sides by 2. This time I'm going to choose to divide the whole thing by 2 just to show you that it doesn't matter which one you do. All right, so once I've got solve for y, my last step is to replace y with f inverse x. So again, f inverse x, and then I just write down what I have over there. I don't change anything at this point except my notation, replacing y with f inverse x. All right, let's try another one. So this one's a little bit different because you can see that the square root is only over the 3x. In this last one, the square root covered the whole thing, but this time the square root only covers the 3x. So that means I'm going to have to attack this one a little bit differently. But I am going to start off exactly the same every time. Put y in place of f of x. I'm going to be real careful here to make sure that my 11 is not inside my square root. Then I'm going to swap out my y and my x. Okay, now the step that's going to be a little bit different, solve for y. Okay, so this time I don't need to square first because the 11 is not inside the square root. In order to get that square root ready to be squared, I need to get it by itself. So let's subtract 11 from both sides. And like last time, I'm not going to write the minus 11 just to save time. Okay, so you see now I have the square root over here. So now I'm ready to square both sides. So pay attention to this. I'm going to square here, but I have to square the left-hand side, right? I'm not just squaring 11. I'm not just squaring x. I'm squaring that whole left-hand side, so I need to use parentheses. Squared and square root are inverses. They're going to cancel each other out. I'm left with 3y. All right, so to get y by itself, I'm going to divide both sides by 3. My numerator does not change. And then my last step, now that I have y by itself, is to replace y with f inverse x. So f inverse x is going to be x minus 11 squared over 3. Now, it's important to notice that if I had to simplify this, if I had to square the x minus 11, this does not equal x squared minus 11 squared over 3. You cannot distribute your squared here. What you would have to do if you needed to simplify this is you would have to write x minus 11 2 times, because remember square means multiply by itself, and then you would have to FOIL that out. First, outer, inner, last, and combine like terms. All right, so if I needed to simplify that numerator, I don't know why my pen did that, but if I needed to simplify the numerator here, x minus 11 squared, this is not what I would get, x squared minus 11 squared. I would get this with that middle term of negative 22x. So it's really important that you write it down 2 times and FOIL it if you need to simplify out that numerator. All right, let's try this one. So x to the 1/2 power, x to the 1/2 power over 18. Okay, so this one looks a little more complicated, but it's going to start off the same way. Put y in place of f of x. And then I'm sure you already know the next step. Swap out the y and the x, just like we did on the last few, just like we did in the last video. All right, and then our next step, solve for y. Okay, so let's see what we can do here. Trying to get y by itself. Y has this exponent on it, but that doesn't affect the 18. So let's multiply both sides by 18. Remember how we did that to clear out the fraction? Divided by and multiplied by are inverses, so they cancel one another out. And I get 18x equals y to the 1/2 power. Okay, so let's pause here just a second. That 1/2 power, that may not be something that you have seen before. But I want you to look back at when we solved for y before. Let's look at this one. When I solved for y, what did I have as my understood exponent? Well, I had an exponent of 1. All right, how about this one? When I solved for y, again, I had an exponent of 1. Going backwards one more time, when I solve for y right here, I had an understood exponent of 1. So what I want to have is not an exponent of 1/2, I want to have an exponent of 1. So do you remember from Algebra 1, when you raise a power to a power, you multiply. And that's what I'm going to need to do here. In order to get rid of this 1/2, I have to multiply it by something so that I'll end up with an exponent of 1, because that's what I want. So I'm going to put this in parentheses, and I'll do the same thing on the left-hand side, because you remember whatever you do to the right, you need to do to the left. All right, so 1/2 times something is going to equal that understood 1 that I want. Well, every time you have a fraction exponent, it's going to be the same thing. Every time you're going to multiply by the reciprocal of that fraction. Because remember, when you multiply fractions, you multiply straight across. 1 times 2 in the numerator, 2 times 1 in the denominator, 2 over 2 equals 1. So what I'm always going to raise this to the power, that's the reciprocal of this one. So in this case, the reciprocal 2 over 1. 2 over 1 is the same thing as 2, so I'm just going to choose to write a 2 there. All right, so I have on this side 18x squared. And on this side, 1/2 times 2 over 1, raising a power to a power, is going to be 1, which is understood, so I don't have to write it. Okay, so if you needed to simplify that, you notice this time that there is no plus in between the 18 and the x. So if you needed to, you could go ahead and square both of those. 18 squared is 324. X squared is just x squared. I'm not sure if Delta Math is going to make you do that or if it's not, but just in case, that's the way you would do it. And then my last step is going to be the same. Replace y with f inverse x. So f inverse x equals one of two choices, either 18x squared or 324 with no parentheses x squared. And you can give Delta Math whichever one it wants. All right, let's try this one. This time, again, a little bit different because now I've got not just x to the 1/2 like I had here, right? You see I just have x to the 1/2. Now I've got x minus 9 all together to the 1/2. So let's see what we're going to do with this one. Start off the same. Nothing changes at the beginning. Replace f of x with y. Okay, good first step. Now let's swap out the y and the x. Okay, now comes our step where we have to do different things every time. Solve for y. Okay, so let's see what we're going to do here to get y by itself. Well, I noticed that the 5 doesn't have anything to do with the 1/2 power. So we can go ahead and move the 5 over to the other side. So let's do that. That 5 is multiplied. Opposite of multiply is divide. So I'm going to get x over 5 equals y minus 9 in parentheses to the 1/2 power. Okay, now you remember we said before we can't distribute that because we have a minus right there. Anytime you have plus or minus in the parentheses, you can't distribute. So I need a different way of getting rid of this power of 1/2. Again, I want it to be a 1. So 1/2 times what is going to give us 1? Well, it's always going to be the reciprocal. So 2 over 1 is the same thing as 2. I'm going to square both sides. All right, 2 and 1/2 multiply together to be 1. So I just have left y minus 9. I don't need my parentheses anymore because the parentheses were for the exponent and we have eliminated the exponent. So still working to get y by itself, I'm going to add 9 to both sides. So I'm going to end up here with x over 5 squared plus 9 equals y. Sorry, that's kind of messy. So on the x over 5 squared, if Delta Math needs me to simplify that, just square the top and I square the bottom. X squared in the numerator, 5 squared in the denominator. All right, and then my last step is to replace that f inverse x. So I'll have f inverse x equals x over 5 squared, or x squared over 25 if that's what Delta Math wants, plus 9. Okay, last one. I thought we'd end on something a little bit easier. All right, let's see what we can do for this one. Let's put y in place of f of x. Okay, now let's swap out the x and the y. Okay, now let's see what we need to do to get y by itself. Well, that -3 is outside the parentheses, so let's divide both sides by -3. And since we've done that, we don't need the parentheses anymore. And so now what we have on the left is linear. That's a little bit easier to work with. Now I'm going to divide both sides by 2.